Hello everyone, Aaron here and welcome back to Leetcode. Today we're doing find closest node to given two nodes problem. You are given a directed graph of n nodes numbered from 0 to n minus 1, where each node has at most one outgoing edge. The graph is represented with a given zero index array edges of size n, indicating that there is a directed edge from node I to node edges I. If there's no outgoing edge from I, then edges I is equal to -1. You are also given two integers, node 1 and node 2. Return the index of the node that can be reached from both node 1 and node 2 such that the maximum between the distance from node 1 to that node and from node 2 to that node is minimized. If there are multiple answers, return the node with the smallest index, and if no possible answer exists, return -1. Note that edges may contain cycles. I'm not sure I understand. So from node 1 and node 2, there is some node I can reach such that the greater of node 1 and 2 is minimized. What? So example 1. Edge is 2, 2, 3, -1. That draws this graph. We're looking at node 0 and node 1. The output is 2 because I can get from 0 to 2 with distance 1 and 1 to 2 with distance 1. The maximum of those two is 1. They're both 1, so the max is 1. This cannot be smaller. Because if we went to 3, they'd both be 2. So the maximum of those is 2. And that is not minimum. Okay. So here, we're starting at node 0 and node 2. Node 0, we can connect to node 1. Node 2 just cannot connect to node 1, so that doesn't matter. Cannot connect to node 0 either. So node 2 can only connect to node 2. So the answer must be node 2 with a distance of 2. Because this is distance 2. This is distance 0. The maximum of those is 2, but that is the minimum distance. So I think what they're asking for is some kind of nearest common ancestor algorithm. So that, for example, if we were to walk from here, meeting the nodes in order, then, and we were to walk from here, meeting all the nodes in order, the first node that they have in common is the answer. And if they have no nodes in common, then the answer is -1. Does that make sense? So for example here, this -1, it walks all possible paths out from itself. So the nodes it can reach is 1, 2, and 3 in that order. From 0, we can walk 0, 2, 3 in that order. The first place that these two meet is at 2. Here we can go 0, 1, 2, and 2. The first place that those two meet is 2. There's no other examples. Okay. if this thing, well, can it branch? Each thing has at most one outgoing arrow, so these must be a chain. There's a chance it reaches back into its own path, but I don't think that matters. So hang on. Chain 1 is self dot chain node 1, and chain 2 is self dot chain node 2, self dot edges equals edges. So what I want to do to begin with is print the list of chain 1 and print the list of chain 2 and define, and let's just return -1 for now. So with this chain, basically what we want to do is cur is start, while cur is not -1, yield cur is self.edges current. So if I'm at 1, 1 can walk to 2, 2 can walk to 3. So I think this works. So let's just run this first, see how far we get. Right, so we saw 0, 2, 3 and 1, 2, 3. So good, we can build chains. And in this one here, we saw 0, 1, 2, and 2. Good, so the chains work. The trick now is, how can I find a node the first node on that chain? There they meet. I can't, because these won't necessarily be ordered, will they? If I turn the first one into a set, for n in chain 2, if n in nodes 1, return n. I'm a little bit worried about this return the node with the smallest index. Is it possible that there are two options? Well, I guess one option would be if it's I'm just trying to think how we could break this. So if we had 0, 1, 2, but we also had 3 pointing into the 1. No, what do I want here? So if we're going from 3 no. This isn't right because this isn't allowed to do this. We can only have at most one outgoing arrow. Can we have this setup where 1 goes to 2 and 2 goes to 1? In fact, what if we turn these around and called them 1? Nah, I don't think that's a counterexample. 0, if it was 0 and 3 that we're starting at. No, what if it was 0 and 4 that we were starting at? 0 and 4. We don't actually need this 3 business at all, I don't think. So the chain from 0 is 0 to 1. If I need a scene here. Zero to 1, because otherwise I would go back around and go to 2 and then to 1 and so on and so forth. So I have to make sure I don't cycle. Whereas if I start at 4, 1, 2. So the options are 1 and 2 are both valid, so I should pick 1. So does that mean if n in nodes 2, op2 is equal to n break, op2 is also none. In fact, I think I want to turn this example into a test case here. So the edges are going to be 0 goes to 2, 1 goes to 2, 2 goes to 1, and 4 goes to 1. And I want to go from 0 and 4. But I also want to do the one where I go from 4 to 0. Oh, that's a 3. Sorry. 0 to 3 and 3 to 0. So the answer should be 1 for both this case and this case. Okay. If op1 none. Hang on. Let's set these to -1. No, let's set these to infinity. In fact, no, they can go to len edges. If op1 equals op2 equals len edges, return -1, return the min of op1 and op2. That's a problem, but not the main one. So what happened here? Oh. It's because this got used up. That's a weird quirk of iterators in Python. Well, not a weird quirk, but a slightly annoying one in this case. But I didn't have to reuse them. I wouldn't have a problem, so let's just stick them in a list. Okay, that seems to be working. I'm a little bit annoyed about having to do this twice, but I can't see a way around not doing it twice. If I could just pick one arbitrarily, I would be fine. But because I have to pick the node with the smallest index, that means I need to search both chains. Let's give it a go. Let's submit it. This may... It's pretty quick, but is there an edge? There's an edge case. So what does this thing look like? We've got 0 goes into 5, 1 goes into 3, 2 goes into 1, hang on, what's that? 0, 1, 2, 3 goes into 0, okay. 4 goes into 2. 0, 1, 2, 3, 4, 5 goes into 4. So that 5 goes into 4, and what is that? 6. Points into 5. 0, 1, 2, 3, 4, 5, 6 points into 5. And we're going from 3 and 2. So from 3, the chain is 3, 0, 5, 4, 2, 1. And from 2, the chain is 2, 1, 3, 0, 5, 4. Yeah, that's the chain. So output 1 is going to be 3, and output 2 is going to be 2. Ah, I see why that's a problem. Okay, I need to change my win condition effectively. All of this is wrong. So what I actually want to do is something more like this. One is n I for I n in enumerate chain 1. Dist 2 is equal to n I for I n in enumerate chain 2. How can I do this without doing it quadratically? For n in dist1 dot keys, no, in fact, n d1 in dist1 dot items, d2 is dist2 dot get n float infinity, min_dist min n is -1. Max d1 d2 is less than min_dist min less than or equal to the min_dist min n is equal to the minimum of n min n. I think that works. And then I just need to do the same thing again. For goodness sake. But this time, oops, for instead of being, that's 2, that's a 1, that's, oops, that's a 2, that's a 1. Whew. Let's do the tests again. I think this is not working. Oh. Obviously that was never going to work, was it? Although it still doesn't work. We expected a 0, we got a 2. Why is that? Print n d1 d2 min_dist min n. I don't quite understand why that happened. I haven't understood my own code apparently. So 0 has distance 0 to itself, but you cannot reach it from node 1. So that oh geez. I need to have infinities not be equal to one another. So we need to do this check here. If it's infinity, don't bother. That's better, but we're still failing this other case. Oops. I forgot to update the min distance. That was a silly mistake. That got lucky with the other ones. There we go. So 0 and 0. So hang on, no, what is this? Node 0 can be reached in 0 steps from node 0, but it cannot be reached from node 1. Node 2 can be reached in 1 step from node 0, and it can be reached in 1 step from node 1. So we're going to update it. Okay. I'm more confident in this now. I hate this repetition, but factoring it out feels gross. Actually, there might be a nice way to do this. For n d1, d2, and what I really want is n dist1.get n float inf dist2.get n float inf. Oops, I got a parenthesis in the wrong place there. For n in range len edges. So now what this should do, in fact, I don't even need to do that, do I? I can just turn that into a D. If I do, oops, max of this and this, oof, that's a horrible line. Let me move that out completely. So dist is going to be this monstrosity. So we collect up n, the node, and the maximum of the distances to it from both starting points, which is potentially infinite. And then we're going to go through all of those. Whew. That should be, well, no, not asymptotically faster. It's still going to be order n. I think the previous version was also order n. It was several multiples of n and a couple of loops there. Whereas now, this is, it's still order 2n, isn't it? It's just been separated to have a lot less code duplication. Right, let's try this again. That was just running tests, but we're back in wrong again. Output 3. Huh? It was working a second ago. What changed in that logic? Oh, I know what it is. If d is less than the min distance, if n equals min n, else no, that just can't happen. There's two conditions that we're dealing with here. One is that the distance is less, in which case we just want to, if the distance is less, then it doesn't matter. Min n is going to be n. If d is equal to min dist, and d does not equal float, min n is the minimum of min n, and then we don't need to actually do anything with that. Is that the logic that we need here? Yeah, that's what we're after. I think this is an improvement. We're getting there. We are getting there. This is a surprisingly tricky problem. We don't need to have these as separate functions. I think, in fact, let's put that there and that there. I think that's nicer. Min dist, min n, that's good. For n, d, n distances. D, yep. Excellent. One last test, because I've just moved some things around. Shouldn't have broken anything. Very good. Let's submit again. Hey, that looks promising. Again, I am not very quick on this one. What have I missed that's obvious, or what have I done that's inefficient, perhaps? Because I'm not too upset with this. I guess... I don't know. There's obviously something I'm doing here that's inefficient. Do you know what I'm doing wrong? Do you leave a comment and let me know, why am I so slow? What have I missed that everyone else seems to have understood here? I found this problem quite difficult to even understand. And I didn't do very well when solving it. So I think I've misunderstood something with this problem. Do let me know down in the comments how it's meant to be done, or how you did it anyway. I'd love to hear that. Do remember to like, comment, subscribe, all of that good stuff, and I will see you next time. Bye.